So please help me and welcome Ms. Dr. Momo, and let's hear it from him. Thank you.
My name is Momo, and I will talk to you about the future of healthcare. This is my favorite phrase, the one I live by every single day, which is the only way to predict the future is to invent it yourself. And that's exactly what my company and what I do every single day. And that's why what I'm going to speak today about, even though it's predicting the future, I know it's going to happen. It's already started. And so let's talk about it. So this is sort of the punchline. So today's healthcare is completely broken. In fact, the term healthcare should not be used for today's healthcare model. Today's healthcare model is really disease management. It's sort of a symptoms management. It's not healthcare. There is no taking care of health. So when someone has a heart attack, that disease started 30 years earlier, and nothing has been done about it until the actual heart attack happens. So the technologies that we have right now are enabling us to prevent that disease decades before the symptoms ever show up. So we're going to enable individuals to take care of their own health and prevent disease instead of waiting until something happens and then manage the symptoms. So this is what's currently happening. We're spending way too much money on healthcare, which is, like I said, symptoms management. And as you can see here, we're spending, on average, twice as much on healthcare as we are on education. And to me, that's simply not acceptable. We need to, this model is not sustainable. The economies cannot sustain this model where the costs of healthcare are rising. And the more money we pour into healthcare, the more people get sick with chronic diseases. Alzheimer's and Parkinson's and depression and autism and so on. So I'll give you an example, and this is a very personal story for me. I had an early onset arthritis, and this seems to be very common these days. I developed my arthritis in my 20s, and by the time I was 35, it was debilitating. I couldn't function as a normal human being. And modern medicine doesn't actually understand at all where arthritis comes from. The only thing they know is how to cover up the symptoms and suppress your immune system. And so luckily, I am very persistent, and I read every possible piece of scientific literature available as a scientist, and I really wanted to solve the problem. I didn't want to suppress my immune system. And so at the age of 40, I identified a science-based personalized diet that worked for me, and my disease completely went away. So it didn't just stop, it completely went away, and I was cured. And so since then, I have had no problems at all, no symptoms at all. I'm perfectly healthy. And all I have to do is follow my personalized diet. And so the reason I started my company is for this reason, to bring science-based personalized diets to everyone. And another reason is that I tried all these fad diets that are out there. Everyone says, oh, Mediterranean diet is the best. Well, that didn't work. Then ketogenic diet is the best. Well, that totally ruined my health, and I will never go back to it. And so there is no one diet fits all. And the reason is because the microbes in our gut are very different in every person. They depend on our environment and our upbringing and what we eat and where we've been and what antibiotics we've taken or not taken and so on. So really we have to have a personalized diet for everyone. So in my particular case, I estimate that I saved the healthcare system probably hundreds of thousands of dollars over my next 2 or 3 decades of my life. And I also, did not lose on hundreds of thousands of dollars of lost opportunity. And I also don't suffer every day. And so that's just absolutely huge. And if you look at the numbers, we spend $53 billion on drugs that cover up the symptoms of arthritis. Instead, why don't we figure out what actually causes it and then stop that, and that way we don't have to treat the symptoms and people don't have to be sick. So this is really the next model. This is what we're going to go into, true preventative medicine. Let's not let the disease take place. So why can we do this now and couldn't do it before? Because the technology that we have available right now is simply was not available earlier. But it's here, and let's use it. There are no technological barriers to this true preventative medicine. And my company is leading the charge, but there are many other companies and governments that are investing into this. So let's play a little game. So is this science fiction? So if someone told you today that in 15 years, you'll be able to drive your car at 100 billion kilometers per hour, right? That's 100 times the speed of light. How many of you would say, yeah, sure, that'll happen, right? that's absolutely crazy. If someone told you that, that's absolutely crazy. That cannot possibly happen, right? It is impossible. And yet, that's exactly what happened in the area of genomics. Exactly. In 15 years, we have scaled that technology 1 billion times. So the example I'm giving here is that a small genomics lab in 2003 was able to sequence 100 sequences per day. And today, that same exact size lab can do 100 billion sequences per day. That's exactly 1 billion times more in 15 years. And not only that, but look at the costs. The first human genome was sequenced for about 3 billion American dollars. And today we can sequence it for $400. In fact, there's a sale going on right now, $299 for a human genome. So this incredible technological advancement is what's going to allow us to study our very, very complex human body and digitize it and understand what health is at the molecular level and what disease is at the molecular level, and then really prevent disease. So I'll give you some examples. So until now, if someone was sick, the doctor had to make a guess as to what caused it. They did one test on that one bacterium or one virus, looked for it, and if it turned out negative, well, then we may do another test for another organism and so on. So it was sort of a guessing game, and it relied on the expertise of the doctor. Today, we can actually identify all microbes and all of their antibiotic resistance all in one test in less than 24 hours, and that's today. In a few years, that'll be reduced down to an hour or two, and maybe even less than that. And so there will be no more guessing game and based on doctors' experiences to find out what you might or might not have. You simply ask all questions at once. So let's use this technology to solve some big problems. So in the areas of infectious diseases, you guys are very well aware that there's a lot of reemergence of infectious diseases. We thought once we invented antibiotics, infectious diseases are going to go away. Turns out antibiotics don't work on viruses, and they spread all around the world very quickly. And there's lots of mutations going on, lots of antibiotic resistance. So really, infectious diseases are not a solved problem. They're reemerging, and they're going to become a bigger problem. So how's the healthcare in terms of infectious diseases going to change? So today, if you get sick, at least in the United States, you go to a hospital. And whatever disease you have, you're going to give it to everyone in the waiting room. And whatever the diseases they brought to the waiting room, they're going to give them to you. So you're going to get a secondary infection from whatever they have. So there's just, all sick people come to one place and exchange pathogens. And so when one person gets sick, the whole city gets sick. So that's really not a good way to do it. What's going to happen is that when you get sick in the near future, you're going to tell your app you're sick and you have some symptoms. A nurse will come to your house and collect a sample within 30 minutes. And today, like I said, it's going to take 24 hours, but in a few years, it'll be just a couple of hours. You're going to get a notification on your app. You have a virus. There's nothing we can do about it. You will not die. Stay home, drink some tea for 36 hours, and then do whatever you want. Or another nurse will come and bring you an antibiotic that the data show will work for whatever you have. So that's really precision medicine brought to infectious diseases. We're not going to be prescribing antibiotics for headaches, which is exactly what happens today. If you have a headache and a sore throat, you can go to a doctor, and the doctor has no clue what you have, but you say, I really want to get rid of whatever I have, give me some antibiotics, and they'll give you antibiotics. So we're overusing them. So chronic non-communicable diseases, these are really the next generation of diseases that are on the rise. And so the ones that I listed are some of the biggest ones. So depression is the #1 disease in the world. About 1/10 of the population has depression, which leads to many, many downstream problems for those people. So we really need to get rid of that. It turns out that the gut microbiome directly controls your brain, and depression is directly controlled by the gut microbiome. So we're going to make some huge progress in depression very quickly here. But all those other diseases listed there are directly affected by the gut microbiome and our environment. And so if you look at that graph that I'm showing, currently in the United States, 1 in 60 children will develop autism spectrum disorder. And if you look at a developing country that doesn't use so many antibiotics and preservatives and is not super sterile, that rate is 100-fold lower. So really, modern life where everything is sterile is not good. We're putting antibiotics and preservatives into everything, we're sterilizing everything to death, and we're leading too clean of a life, and we don't spend time in nature. So we really need to change that. So what determines health versus disease? So our body has 20,000 genes that are human genes, but we also have 1 million genes coming from our gut microbiome. And so it's really the gut microbiome that controls our health and disease the most, and they produce tens of thousands of chemicals that we depend on. So if you look at the balance of health and disease, it's really the human genes, the microbial genes, the environment, and the diet that all determine health or disease. So what is the human gut microbiome, or microbiome in general? So there are 40 trillion microorganisms living on our bodies every day, on every one of us, and 99% of those organisms live in our gut. And they're associated with most chronic diseases. And the nice thing about the gut microbiome is that we can change it. We can't change our genes, but we can change our gut microbiome fairly quickly. You just start eating a different diet. And that's why some of these diets work really well for some people. So that's a very important concept. So let's talk about a specific case where we can use gut microbiome to help with our health. So you all have likely heard about the glycemic index. So diabetes is a huge problem worldwide, and it's a really rapidly growing disease. And glycemic index is a very important thing. It tells you basically for any food how high the blood glucose will reach in your blood. And the glycemic index, if you go look it up on Google, it'll show you the average person glycemic index. It turns out that none of us are average. We're all different. And so I'll show you here, we've done a large study, and here's just one example where two people are fed two different foods, and they respond completely differently to those different foods. In one case, one food spikes the blood sugar really high, and the other one does not, and in the other person, it's completely the reverse. And so by looking at that average glycemic index, it doesn't really tell you anything. It just tells you what the average person is like, but that doesn't exist. It's you here. So we really need to bring personalized medicine, precision medicine to this area and enable people to manage their blood glucose without having to guess. So how did we do that at my company? So we ran a large clinical study. We enrolled 550 people, and we fed them 25,000 meals over a period of a year. So it was a very large study. And we monitored their glucose, and we performed our gut microbiome test. And we fed this vast amounts of data into a supercomputer and developed machine learning models that can now predict for every single person what their personalized glycemic index is. So our customers, in about a month, will have the ability to provide us with a stool sample, and once we analyze it, we can tell you exactly how each carbohydrate-rich food, either alone or in combination with certain fats or certain proteins, will spike your blood sugar. And that way, whether you're healthy or pre-diabetic or diabetic, you can manage your sugar, and it's just for you. You don't have to look at the average. So this is a science-based diet to fight diabetes, and the technology is here, so let's use it. So I'm really excited about pancreatic cancer, for example. We're launching a study on that. So right now, if someone asks you, will you get pancreatic cancer? The answer is, I have no idea, right? No one knows. It's a completely random chance, it seems. But it turns out that pancreatic cancer is caused by bacteria that live in our guts, in our intestines. And so now we're on a quest to figure out exactly what are the molecular events that lead to pancreatic cancer, and then we will likely be able to prevent them with simply a personalized diet. And then what I'm hoping is that we're going to have on our app a graph that looks something like that, where we show you if the graph is flat, that means you will not get pancreatic cancer. If it starts to go up, then you're in danger of getting pancreatic cancer. You better follow your diet and knock it back down. But you'll have a readout of what's going on at the molecular level. If you don't have that, a genetic test today may tell you you have a 3.2% higher chance of developing pancreatic cancer. What are you going to do with that information? Absolutely nothing, right? You're not going to stop doing what you're doing. You're not going to change your lifestyle or diet. But if you see it live on the graph, if you do this test every 3 months and it starts to go up, you're going to know that at the molecular level you might get this disease. You are getting the disease, and you're doing this pre-symptomatically, and so you're going to change your behavior because you're getting real-time data. You're not getting some chance. So it's very actionable. So what's the future of healthcare going to look like? So we're going to enable individuals to take control of their health and not wait until they have disease. That's really the biggest concept here. And another concept is that everything's going to be done at home. There's not going to be a need to go to a hospital unless you have to have a surgery or unless you have an accident. So that's really going to change. And we're going to be providing people with personalized diet and lifestyle recommendations. Exactly what to eat, how much to eat, and what probiotics and prebiotics and supplements to take. And fasting is a big next frontier in science. I think it's going to become very, very important, and we need to put science behind it instead of guessing. People don't like to fast. And then exercise is going to be personalized, and sleep is going to be personalized. So let's summarize how we're going to get to that future, what needs to happen. So as countries and governments, the leadership really needs to consider these actions. So we need to train clinical and data scientists. So the amount of data that a single test these days generates, remember, we went a billion-fold more, right? So currently, one test can generate thousands of times more data than someone who is 80 years old has collected throughout their entire lifetime, right? Thousands of times more data, just one test. And if we do multiple tests every 3 months, the amount of data we generate is vast. And when you do that on a population scale, you really need some big supercomputers, and you need people who are trained to analyze such vast amounts of data. And so we need to train a lot more of those people, and we need to train people who can run clinical studies. The second line there is, I think, the most important. We have been funding mouse research for decades, and we know how to keep mice very healthy. Unfortunately, that doesn't help at all to us, right? That research does not translate into human health. And so we need to stop getting mice healthy. We need to transfer everything to humans. So we need to fund large studies. Unfortunately, there are complications with running large human studies, but it's a worked out problem. We know how to solve it. So let's do that. And the key word there is large. If you do a study on 6 humans, you're not actually going to help the rest of the country. You're not. You're only going to help those 6 humans. And so we really need to have hundreds or thousands, or preferably even more, humans enrolled in these studies. And that's not a problem if you make it easy. Our study participants are very happy to participate, so we can make it very fun. So we need to provide less expensive computing so we can analyze all these data. And then we really need to educate the public. So this is sort of a new concept. The public is used to waiting until they have a heart attack, or wait until they have Parkinson's or Alzheimer's or diabetes, and then they go to a hospital and hope for a pill that will solve their problem. That's what basically people are trained to do. We need to retrain them to think that we can take control of our own health and maintain health and prevent disease from ever happening. So we need to teach them the power of prevention and the importance of these personalized diets. Thank you very much for your attention.